Have you ever stopped to think about what's really going on inside your phone or your computer? I mean, there's this invisible force, this hidden boss that's running the entire show, from your car's dashboard to your gaming console. Well, today, we are pulling back the curtain on that silent commander, the operating system. Let's dive in and figure out how it all actually works.
Just think about it for a second. You tap an icon, you click a button, and stuff just happens. But how? How does a piece of glass and silicon understand that you want to open an app or send a message? That single, simple action kicks off an unbelievably complex chain of events. And that's the question we're going to unpack right now.
And the answer, the secret sauce, is the operating system, or OS for short. You can think of it as the ultimate translator. You speak human, with taps and clicks, but the hardware, the chips and wires, they only speak machine code. The OS is that genius in the middle that makes the conversation possible, managing all the computer's resources so your apps can do their thing.
Okay, so if the OS is the boss, what's actually on its job description? Well, it turns out it's a bit of a jack of all trades, a master manager that has to keep the whole system running smoothly. And its duties are, well, they're huge, and they are absolutely critical. Here's just a quick look at its to-do list. It's in charge of the computer's brain, the CPU, and its memory. It juggles all the programs that are running, which we call processes. It handles every single file you save. It controls all your gadgets, like printers and keyboards. It gives you the very interface you see and touch. And it has to keep the whole thing secure. Yeah, it's a big job. To really get a feel for what the OS does day in and day out, let's zoom in on two of its most important jobs: how it manages the computer's memory and how it juggles all of those programs at once. Okay, so check this out. The OS is like a super strict librarian for the computer's memory. When you run an app, the OS gives it its own little workspace. Part of that is the stack, which is for really fast temporary data, kind of like a neat stack of notes for quick jobs. Then there's the heap, which is a big, flexible area for data the app needs to create on the fly. And here's the crucial part. The OS makes sure no program can mess with another program's memory. This isn't just about being tidy. It's the reason one buggy app doesn't crash your entire computer. And that brings us to a really key idea: a process. See, a program just sitting on your hard drive is just a file. It's passive. But the second you double-click it, the OS breathes life into it and turns it into an active process, a program that's actually running. And if you look at your device right now, you've probably got dozens, maybe even hundreds of these processes all running at the same time. And this is where the real magic of multitasking happens. Your computer's processor, its core, can technically only do one thing at a time. So how does it feel like everything is happening at once? Because the OS is an incredibly fast juggler. It's constantly switching between processes. A process might be running for a split second, then another one that was ready gets its turn. If a process needs to wait for something like the network, it gets blocked. By shuffling between these states thousands of times every second, the OS creates this perfect illusion that you're doing everything simultaneously. So now that we have a better idea of what an OS does, let's talk about how many of them there are, because it is definitely not just Windows and macOS. The universe of operating systems is huge, with a really fascinating history. I mean, the whole journey started back in the 50s with these giant machines that could only run one job at a time. Then the 60s hit, and we got time-sharing systems like Unix, which was revolutionary because multiple people could use one computer at once. Fast forward to the 80s, and we have systems that can manage resources across networks. And today, we have incredibly precise real-time systems that run everything from the anti-lock brakes in your car to a Mars rover. And that evolution has created this incredible, sprawling family tree of operating systems. The sheer number that have been developed over the years is just mind-boggling. So let's do a quick flyby of some of the biggest dynasties that have shaped our digital lives. You have to start with a true titan, IBM. They built the foundation with things like OS/360 for mainframes, and its descendants, like Z/OS, are still the bedrock of global finance today. Plus, they were right there at the dawn of the personal computer with PC-DOS and the super ambitious OS/2. And then, of course, there's Microsoft. I mean, from the old-school command line of MS-DOS to the graphical boom of Windows 95, the rock-solid stability of Windows XP, and all the way to Windows 11. Their OS has pretty much defined what a computer looks like for generations. And you can't talk about Microsoft without talking about their biggest rival, Apple. They took a totally different approach, building this whole ecosystem of tightly linked operating systems. It started with a friendly face of the classic macOS, grew into the powerhouse that is macOS, and then just took over our pockets with iOS, our wrists with watchOS, and now our faces with visionOS.
And we can't forget Google. Their strategy has been completely different but just as massive. Their Android OS, which is built on Linux, powers the overwhelming majority of the world's smartphones. They've also got the super lightweight, cloud-first ChromeOS for laptops, and they're even building a brand new OS from the ground up called Fuchsia. And believe me, this is barely scratching the surface. We haven't even really talked about all the different flavors of Unix, which is the grandparent of so many modern systems, or some of the cool, innovative ones like BIOS. The list just goes on and on.
Now, all of these different operating systems, you can pretty much sort them into two big camps. And it all comes down to a fundamental philosophical difference in how they're built and shared. This is the great debate, open versus closed. So, on one side, you've got proprietary systems. This is where the source code, the actual blueprint for the OS, is a closely guarded company secret. They have total control. The best analogy is a secret recipe, like the one for Coca-Cola. Then you have non-proprietary, or what we usually call open source. Here, the source code is out there for everyone to see, to study, and even to change. It's like a community cookbook, where anyone can add a recipe or improve an existing one.
And here's the thing. Both of these philosophies have led to massively successful systems. In the proprietary, secret recipe world, you get the polished, controlled experiences of Windows and macOS. And in the non-proprietary, community cookbook world, you get things like Linux, which is the absolute backbone of the internet and the core of Android, along with other powerful systems like FreeBSD.
So, we've seen where the OS came from, we've seen what it does, but where is it going? In a world that is changing faster than ever, is the operating system still going to be the boss? At the end of the day, the operating system is, and probably always will be, the unsung hero of computing. It's this incredibly complex, totally invisible engine that makes our entire digital world go. It's so easy to forget it's even there, but without it, our shiny devices would just be, well, expensive bricks.
And that kind of leaves us with one big final question to think about. As more and more of our digital lives move into the cloud, and as AI gets baked into everything we use, what happens to the good old OS on our actual device? Is its role going to shrink? Or will it actually become more critical than ever before, the key to managing all this new complexity? Honestly, the answer to that is going to define the next era of technology.
Don't forget to like, follow, drop a comment, and check the links below.